Because for the most part, determining if something is a polynomial function or not is mainly just looking at it. Because if we look at these here, if their variable is negative, or not the variable, if the exponent is negative, fractional, or has a variable, it's not going to be a polynomial function. If the variable is in the bottom of a fraction inside of a radical, it's not going to be a polynomial function if we have two variables multiplied together.
Do the following students please come to the office? Shannon Swellinger, Alan Tyson, Taylor Tyson, Riley Shelley.
So if we look at this here, number one is going to be yes, because the variables, well, all the exponents are natural numbers. We don't have any fractions. We don't have any negatives. And we don't have any variables. We don't have variables in the bottom of a fraction or inside of a radical or two variables multiplied together. Now, number two is no, because we have x to the negative third. We can't have negatives inside, or negatives as an exponent. Because really that's saying that we have 6 over x to the third. Because if an exponent's negative, we make it positive by moving it from the numerator to the denominator, then it's in the bottom of a fraction. If we look at number three is going to be, yes, all the exponents attached to the variables are all positive. We do have one fraction, but the variable's in the numerator. And the last one is no, because we have a variable inside the radical. Now, this here, square root of 3 times x is fine because the x is not actually in the radical, it's outside. Any questions on 1 through 4? 5 through 8, from the given zeros, find the polynomial function. So really this is setting each one of these equal to 0 and then multiplying them together. So we can look at number 6. Now number 6 is saying that x is equal to negative 2i. X is equal to the square root of 3, and x is equal to negative 2. Now, these aren't all the zeros that we have, because if x is equal to negative 2i, x is also equal to 2i. Because if we have I, we have to have the positive and negative version of I. Also, with the square root of 3, if I have positive square root of 3, I also have to have negative square root of 3. Because this is going along with the fact that if a plus bi is a solution, so if x is equal to a plus bi, x is also equal to a minus bi. The same thing is true with radicals. If x is equal to a plus the square root of b, then x is equal to a minus the square root of b. If we have one, we have to have the other. Now at this point here, we just get all these equal to 0. So for the first one here, we would just subtract 2i, telling us x minus 2i equals 0. For the next one, we would add 2i, telling us that x plus 2i equals 0. Do the same thing with the radicals. Get those equal to 0. And the last one we just add 2. Now once we do this here, our next step is to multiply all these together. We're going to multiply all these together. Now, whenever we multiply these together, I would always start with the conjugates, or complex conjugates, or irrational conjugates. Multiply them together first. Now, if we don't have any complex conjugates or irrational conjugates, factors with I or factors with square roots, it doesn't matter which order we multiply them, just multiply them 2 at a time. But here, we're going to multiply x minus 2i and x plus 2i first. Parentheses. We'll do x times x, which is x squared. X times 2i is going to be plus 2xi. Negative 2i times x is negative 2xi. And negative 2i times 2i is going to be negative 4i squared. We'll do the same thing with the next set. X times x would be x squared. X times square root of 3 is going to be plus square root of 3x. Negative square root of 3 times x is negative square root of 3x. And negative square root of 3 times square root of 3 is negative 3. Because our square root of 3 times the square root of 3 is the same as saying the square root of 3 squared, which is just 3. Or we could say the square root of 9. Well, the square root of 9 is still just 3. Now at this point we could multiply again, but I would want to simplify, combine like terms. Because if we look at the first one, 2xi minus 2xi is 0. So all we're left with is we have the x squared, and we have negative 4i squared. Well, what is I squared? Negative 1. Negative 4 times negative 1 is really just saying that this is plus 4. Parentheses. Our next one, square root of 3 times x minus square root of 3 times x. This is 0, leaving us with x squared minus 3 times x plus 2. So we need to do 2 more multiplications and then we're done, so we can multiply the first 2 here. So we can say x squared times x squared, which is x to the 4th. X squared times negative 3 is negative 3x squared. And we multiply by 4. 4 times x squared is plus 4x squared. 4 times negative 3 is negative 12. And again, before I multiply the last 2 together, I would combine like terms, because it's going to make it a little bit easier to multiply through. And our last one, x to the 4th times x is x to the 5th. X to the 4th times 2 is plus 2x to the 4th. X squared times x is going to be plus x cubed. X squared times 2 is going to be plus 2x squared. Negative 12 times x is negative 12x. And negative 12 times 2 is negative 24. And this here is our function. We can still have it set equal to 0, or I can say f of x. Either works. But this here is the final answer. And it won't always work out that none of our, once we finish multiplying the last 2, that nothing will combine. It just worked out here that that's how it worked out. Any questions on these here? Any questions on any of these so far? Questions on 7 or 8? So we look at 7. Now if we set up the zeros, we'll have x equals 6, x equals negative 4, and x is equal to 1 minus 3i. So if x is equal to a plus bi, x is equal to a minus bi. Since we have 1 minus 3i, we also have to have 1 plus 3i. And the same thing's true with radicals. If we have them combined like I squared root of 3, we'll also have negative I squared root of 3. Now all we need to do is get each one of these equal to 0. Here we're going to have to minus 1 from both sides, and then add 3i. So when we find the other one with I or radicals, we're really only changing the sign in front of the I and or radical. And even on the last one, even though we have I squared of 3, we're not going to have 4. We're just going to have I squared of 3 and negative I squared of 3. Again, at this point, we can multiply them out. Now, the two that I know I'm going to multiply together for sure are going to be these two. I don't want to combine them with any others. Now, it doesn't mean we don't have to wait for the x minus 6 and x plus 4. We can still multiply those out. X times x is going to be x squared. X times 4 is going to be plus 4x. Negative 6 times x is negative 6x. Negative 6 times 4 is negative 24. I just don't want to multiply the x plus 4 and x minus 1 plus 3i. That's going to make things a lot harder than they need to be. So we multiply these two here. We have a lot more terms than last time. X times x is going to be x squared. X times negative 1 is negative x. X times negative 3i is negative 3xi. Then we multiply through with the negative 1. Negative 1 times x is negative x. Negative 1 times negative 1 is going to be plus 1. And negative 1 times 3, negative 3i, is going to be plus 3i. And lastly, we multiply through with 3i. 3i times x is going to be plus 3xi. 3i times negative 1 is negative 3i. And negative 3i times 3i times negative 3i is going to be negative 9i squared. A lot of terms. And the nice thing with most all these terms is we do have things that combine. In our first set of parentheses, we're going to have x squared. 4x minus 6x is going to be negative 2x minus 24. In our next one, well, negative 3xi and positive 3xi become 0. Positive 3i, negative 3i, those become 0. And the only other spot we have I is at the end with negative I, 9i squared. But I squared is negative 1, which is really just going to make this plus 9. Because negative 9 times negative 1 is going to be positive 9. And once we have all the i's gone, we can combine our like terms. So we'll have x squared. Negative x minus x is negative 2x. And 1 plus 9 is going to be plus 10. And last but not least, we've got to multiply these two together. So we multiply through with x squared. X squared times x squared is x to the 4th. X squared times negative 2x is negative 2x cubed. And x squared times 10 is plus 10x squared. Then we multiply through with 2x, negative 2x. Negative 2x times x squared is negative 2x cubed. Negative 2x times negative 2x is going to be plus 4x squared. And negative 2x times 10 is negative 20x. And lastly, multiplying through with negative 24. Negative 24 times x squared is negative 24x squared. Negative 24 times negative 2 is going to be plus 48x. And lastly, negative 24 times 10 is negative 240. And last but not least, we're going to combine like terms. X to the fourth is going to be by itself. It's the only term that has x to the fourth. We have 2x to the thirds, so negative 2x to the third minus 2x to the third is negative 4x to the third. 10x squared plus 4x squared is 14x squared, minus 24x squared is negative 10x squared. Then we have our negative 20x plus 48x is going to be plus 28x minus 240. And that there would be our final answer. Any questions on any of this here? So we can look at this one here, 9 and 10. So we're just answering these questions based off the parabola given. So the first one, does the parabola open up or down? Well, this one's going to open up. And again, that's all based off A. Or what we could do, 3 times x plus 1 squared minus 48. Okay, we see it opens up. Yes. Now the axis of symmetry is given to us by the equation x is equal to h based off of the vertex, which is our vertex, is our h comma k. And where do we get h and k from? From the equation itself. Now the vertex for this here, h comes from inside the parentheses, and since it's positive 1, it comes out as negative 1. K is exactly as we see it. So the vertex is negative 1 comma negative 48. The axis of symmetry is x is equal to negative 1. Questions on this so far? Now the x-intercept and y-intercept. X-intercept is where it crosses the x-axis and the y value is 0. The y-intercept is where it crosses the y-axis and the x value is 0. Luckily for us, if we type this into the calculator, we can find both. Because here, when x is 0, the y value is negative 45. So our y-intercept is 0 comma negative 45. And we'll put them as points. Negative 45, I will take negative 45 or 0, 45. Now the x-intercept is where it crosses the x-axis where the y value is 0. Well, one of them is 3, 0. And the other one, if we scroll up, is negative 5. And we get both of these here. Questions on any of this so far? Now, if we wanted to solve this mathematically, because it's already set up in a set of parentheses squared, we can use the square root method to solve it. X is only inside those parentheses. So we move the 48 over. Divide both sides by 3. telling us x plus 1 squared is equal to 16. We could square root both sides, telling us x plus 1 is equal to plus or minus 4 minus 1. X is equal to negative 1 plus or minus 4. X is equal to negative 1 plus 4. And x is equal to negative 1 minus 4. Negative 1 plus 4 is 3. Negative 4 minus 1 is negative 5. It is the two that we found. Now the main reason we would need to do this is if we didn't get two nice intercepts, where we get nice integer answers. Now the last part, domain and range. The domain is going to be what? All real numbers. For any higher degree polynomial function, the domain is going to be all real numbers. Because radicals, even radicals, and rational expressions are the only ones we really have restrictions for. The range, since it opens up, the biggest value of the range we're going to have is positive infinity. If it had opened down, the smallest value we could have would be negative infinity. If it opens down, we're going to have negative infinity in the range. If it opens up, we're going to have positive infinity. Now the smallest value that we have for this here is going to be the y value of the vertex, which is negative 48. Since it opens up, the y value of the vertex is the smallest value. If it opens down, the y value of the vertex is going to be the biggest. And that's it. Questions on this here? And again, with these here, the first place you can start out with is graphing them, just see how they look. And this one here, it opens up. One way we can tell that it opens up is by, well, one, graphing it, and also the value of a is positive. If the value in front of x squared, or the value in front of those parentheses is positive, it's going to open up. If it's negative, it opens down. Axis of symmetry, vertex. Well, all these would be helpful if we had it in, make sure, yep, vertex form. So even though it is f, it's going to be good to have it in vertex form first because that'll help us get the rest. Now vertex form, we're going to have to complete the square. And to complete this square, we have our c is equal to b over 2 squared. Now normally we would need the number in front of x squared to be 1. Here it is. And we're not going to focus too much on it not being the case. So our value b is negative 11. Does 11 divide by 2 nicely? No. So we're going to leave it as that there and go on and just square it. So if we square negative 11 halves, we get 121 over 4. Now the value of c that we plug in will always be positive. The value itself, we're going to add it and subtract it. And what I mean by that is c, once you simplify and find c, you're not going to have c is equal to negative 121 over 4. Because if we square a number, multiply it by itself, it's going to be positive. So we have this here. Now inside the parentheses, we'll have x, and then whatever was inside the parentheses before we squared it with finding c, which was negative 11 halves. So inside the parentheses, we have x minus 11 halves squared. Now negative 121 over, not 7, 4 plus 30. Nope, I don't, just, yeah, that is 4. is negative 1/4. I find that kind of interesting that it works out to be such a nice number. But we get this here. This is the equation in vertex form. Now that's very helpful because one, it does give us the vertex. Vertex is our h comma k. H, the number inside the parentheses, is negative 11/2. So it becomes just 11/2. And the outside number is going to be negative 1/4. So that is our vertex. The axis of symmetry is the value that goes through that point. X equals h. X is equal to 11/2. And that just leaves us with x and y intercepts, domain and range. Now again, we could do like we did before, set this thing equal to 0 for set y equal to 0, solve for x. Set x equal to 0, solve for y. Well, when x is 0, the y value is 30. So the y-intercept is 0, 30. And whenever it's in standard form, we can just plug 0 in both of these here, and we're just left with 30. Now the x-intercept is whenever the y value is 0, which is at 5 and 6. 5, 0 and 6, 0. Domain is all real numbers. Range. Since it opens up, we will have a minimum value, but we won't necessarily actually have a maximum value because, again, it continues indefinitely in the positive direction. Our minimum value is y value of the vertex. Questions on this here? We're ready for the next one. Questions on 11, 12, or 13? One of these in particular that y'all want to look at? Now again, with most of these here, the first thing I would do, first place I would look, is graph it. I plug it into the graphing calculator. Because any of them here that are solutions are going to give us a y value of 0. Because if it gives us a y value of 0, it means it's a solution. So x to the 4th. Austin, if you'll read that off to me. Graph. Okay, so we do see two spots that it does cross your x-axis, or at least hits it, yes? Let me say second table. So -4 and 3. How many solutions should we have? 4, because the degree is 4. And we can check this to make sure, so we can say -4, 1, 2, -23, -24, 144. Well, -4, and go through synthetic division. Because if it does give us a remainder of 0, then it is a solution. So -4 times 1 is -4. 2 plus -4 is -2. -4 times -2 is 8. -23 plus 8 is going to be -15. negative 4 times negative 15 is positive 60. Negative 24 plus 60 is going to be negative 36, which ends up giving us negative 144. Now the question is, did it actually cross the x-axis at negative 4? Well, if it didn't, then we actually have a multiplicity of 2. We have an even multiplicity with it. So we can try negative 4 again. Negative 4 times 1 is negative 4. Negative 2 plus negative 4 is negative 6. Negative 4 times negative 6 is positive 24. 15 plus 24, negative 15 plus 24 is positive 9. Negative 4 times negative 9 is negative 36, which does indeed give us 0. Which, okay. So we know negative 4 is a solution. What do we think the other solution is going to be? 3, yes? Because we can't have the other solution be irrational. It can't be a radical. Because if I get, say, the square root of 2 as a solution, I also have to have negative square root of 2. Well, we've already found 3 solutions. I only have 1 left. Can't be radicals, can't be i's, so most likely it's going to be 3. And if we go through this, we do get this left, which is just saying x minus 3 is 0, so x is equal to 3. So the solutions for this one here are 3, 3, negative 4, and negative 4. All right. Next one. X to the third. Minus 35x squared. Awesome. So this is kind of nice to see. We do see that it crosses the x-axis 4 times, which means there are 4 solutions. However, 2 of them do not look nice. So we go to second graph. So one of them we do have is 6. Now I did see another negative. So if we keep going up, negative 5. So that does give us 2 solutions, and it gives us a place to start with our synthetic division. Now it really doesn't matter which number we start with, because I could start it off with negative 5 or 6, either one. You just got to pick one to start with. And do synthetic division. 6 times 1 is 6. Negative 1 plus 6 is 5. 6 times 5 is 30. Negative 35 plus 30 is negative 5. 6 times negative 5 is negative 30. And negative 30 plus 5 is negative 25. And 6 times negative 25 is indeed negative 150. And 150 plus negative 150 is 0. Now we do the same thing with negative 5. 1 times negative 5 is negative 5. 5 plus negative 5 is 0. Negative 5 times 0 is 0. Negative 5 plus 0 is negative 5. And lastly, negative 5 times negative 5 is positive 25, which gives us 0. Now at this point here, we have to plug the variables back in because we're going to solve. And the whole reason we did this is to, one, get it from a fourth degree polynomial down to a quadratic. Because if we get it down to a quadratic and we have a middle term, we can use the quadratic formula. Or b squared minus this, or sorry, yeah, negative b plus or minus the square root of b squared minus 4ac all over 2a, our quadratic formula. Or here, since we don't have a middle term, we can use the square root method. We can add 5 to both sides. Minus x squared is equal to 5. Square root both sides, telling us x is equal to plus or minus the square root of 5. So that there would be our other two terms. Now again, at this point, if you want to check to make sure that you got the correct answer, you can do that with the graphing calculator. Because what we can do is say second trace, which is our calculate, and the first one is value. Second square root of 5. Enter. Tells us the y value is 0. Now if you get something like 2.4 e to the negative 12th, number like that for y, that's essentially 0. It's just saying it's significant, it's just a pixel size off. And we can do the same thing with negative second square root 5. We get 0. Questions on any of this here? Use Descartes' rule of signs to determine the number of possible positive, negative, and complex zeros. So when we do this here, we're counting the number of sign changes. So for the positive case, we can just count the number of sign changes as we have it here. So from 4 to the third, we do have 1. From x cubed to x, we have 2. And from x to our constant, we have 3. So the most positive zeros, positive possible zeros, is 3, or less than it by 2. So we could say we have 3, we have 1, and that's it, because we just subtract 2 from it. So 3 minus 2 is 1. We can't minus 2 from 1 and get a positive number. So 3 or 1. Now the next thing to do to find the negatives is, well, we replace every x with negative x. Now, in the first time we went over this, we did go through and put in parentheses negative x in every spot. An easier way, I think, to do this is we look at the exponent. If the exponent is even, the sign stays the same. If the exponent is odd, it changes. So the first one, 5x to the fourth, well, the fourth power is even, so it's going to stay positive 5x to the fourth. Now, since the next one's odd, the sign's going to change from negative to positive. So we have plus 7x cubed. The next power is odd, so it's going to change to negative 15x. And the 7 doesn't have a variable, so it's just going to stay negative 7. Questions on this here? So the way I look at this, and I think that not too bad, if the exponent's even, keep the sign the same. If the exponent is odd, change the sign. And after we do that, we're going to count the number of sign changes. Not so much in plugging it in, but from going from one term to the next. From the fourth to the third, it doesn't. From the third to x, it does. Last one, it doesn't. So the number of negatives is 1, or an even number less than it, but we can't take 2 away from 1 and get a positive number. So the only set we have is 1. Now I'm going to set the table up to figure out the number of complex that we can have. And the way I always start this is the most positives we can have and the most negatives. So 3 and 1 is 4. The number of solutions we are looking for is indeed 4, so we have them all, yes? Then I start subtracting 2 from the negatives. Can we take 2 away from 1? No. So since I can't do it with the negatives, we do it with the positives. If we have one positive, one negative, that means we have two complex. Then I would keep subtracting with the negatives till I can't anymore, reset it, do it once with the positives. But since we can't subtract any more in either case, we're either going to have three positives and one negative, or one positive, one negative, and two complex. Any questions on the rational zeros? Or not rational zeros, sorry. Descartes' rule of signs. Do we feel comfortable with Descartes' rule of signs? Yes? Let's see here. Yep. We will have to finish this up tomorrow. Your test will be Wednesday, Thursday.